I learned in grade 9 that if you have a square and then any other type of rectangle, then if they have the same perimeter, then the square will always have a greater area than any other type of rectangle that you can make. Now, that's nice, but how can we prove that? In grade 9, I couldn't prove it. So let's prove it now. So let's first assume that we have a rectangle. Well, the information is given that the rectangle has perimeter P. So let P be the perimeter of this rectangle. Now we want to reshape the dimensions such that we get a rectangle with maximum area while still having the perimeter P. So let's say that this rectangle will be the rectangle with maximum area, right? Just assume that it's this one. So then this rectangle has length L, and this rectangle also has width W. So W is its width. So then we can set up an equation. Notice that 2L plus 2W, that's just the perimeter of the rectangle. So then that's just equal to P. In addition to that, what is the area of this rectangle? Well, that's just L times W. This is equal to the area. Set that as A. Okay, so now let's go ahead and rearrange. We'll rearrange for L. So we'll go ahead and do 2L is equal to P minus 2W. Alright? And then now we can divide both sides by 2 to get L in terms of W. Now, just a note, the perimeter is fixed. We know what the perimeter is. We just need to find the maximum area. And we need to find also the dimensions that will give the maximum area. So anyways, we have P over 2 minus W after dividing both sides by 2. So then now, let's substitute this into this. So let's go ahead and do this to this. So then if we replace L with this, we just get P over 2 minus W times W is equal to area. So then you can multiply the W inside. So we have P over 2W minus W equals to A, the area. So then now we're going to rearrange, and we have negative W squared plus P over 2W is equal to A. Alright, so now let's consider this equation. Let's factor out a negative 1 on the left side. So we have negative W squared minus P over 2W. This is equal to the area, A. Okay, so now what we can do is we can complete the square inside here. So we can go ahead and take half of the coefficient of W, which is P over 2, and then we square it. We add that, and then we have to subtract it back. So then we have negative, and then W squared minus P over 2W, and then we have plus P over 4 all squared. And then we have to subtract this back because you can't just add something for free. And then you have this equal to the area. So then now we can complete the square for this part. So then let's go ahead and complete that square. We have negative, and then now this entire blue underlined part, this becomes W minus P over 4 all squared. Remember, we still have this minus P over 4 all squared, and then this would just be minus P squared over 16, sorry. There we go. And then we just have this equal to the area. So then now let's go ahead and bring this negative sign back into the equation. We just have negative W minus P over 4 all squared, and then plus P squared over 16. And then now this is just equal to the area. So now consider this. This is just a quadratic maximum or minimum problem. What value of W will maximize A? Well then, we know that in order for it to be maximum, this inside the bracket here needs to be 0. Because notice that there's a squared here, so it's always going to be positive, but then there's a negative sign here, so it's always going to be negative. So therefore, you need to make this 0 to make it maximum. And when W is equal to P over 4, then we know that this will be maximized. The A value will be maximized. So therefore, we know that in order for this to have maximum area, this width here must be P over 4. So a quarter of the perimeter, that is. Now, what is L then? Well, again, using our original equation, we can solve for L in terms of P. And then that will substitute W with P over 4. Then we just have 2L plus 2 times P over 4 is equal to P. Right, correct? And then, I need more space. And then, let's solve for L. We just have 2L is equal to P over 2 is equal to P. Subtract P over 2 on both sides. We have 2L is equal to P over 2. Divide by 2 on both sides. We have L is equal to P over 4. So the length is also P over 4. So therefore, let's see what happens if we replace L with P over 4. Okay, well, notice that the side length of this rectangle is all P over 4. Therefore, since all of its side lengths are equal, this must indeed be a square. In order to obtain the maximum area, you need to have the dimensions, the length times width, to be respectively P over 4 times P over 4. Right? And in addition, you can see what the maximum area is. It's just P squared over 16. And notice that when you do P over 4 times P over 4, you do indeed get P squared over 16. And that's the maximum area. Alright, so that's the end of this video. Please do consider subscribing if you learned something new from this, and I'll see you next time.